Hello everyone, my name is Martin Linksfeld and I am Master Chef at foggykitchen.com. It is the third lesson in my self-study course about using Terraform for provisioning Oracle Cloud Infrastructure resources. In the previous class, we have created OCI infrastructure with two web servers, exposing simple web pages to the external world, meaning the public internet. Instead of one, two web servers have redundancy and high availability. There is only one small problem with this setup. Hosts are fully independent. Each server has a dedicated public IP address, so that means you can get each web server's copy independently. It is not like in a real-world scenario, because in real-world scenario, you have only one URL address or only one IP address where you can get the web page. So in our case, we need to have load balancer umbrella under which we will hide the complexity of web servers and cloud infrastructure. Then we will have just one IP address to get the page, no matter how many elements we'll lay under the hood. And this is the topic of this class. Let's go to the topology diagram to verify what new parts I have added. Okay, this is a topology diagram for lesson 3. As you can see, we are following the concept of a single AD region, and we are using full domains to spread the servers inside one AD, right? On the other hand, still we have two web servers, right? And the only one thing which has been added is a load balancer. Load balancer is highly available, and we have a primary entity and standby entity in case of any failure in full domains. And it means the traffic will go through the load balancer to web servers. Now we can move to our code and code editor just to see what has changed in Terraform. Okay, now I am again in my local repository. I will go directly to lesson 3, load balancer. And in this lesson, we have new file, loadbalancer.tf file, where we are defining all elements, all resources related to the load balancer. First resource is OCI load balancer. For this load balancer, we are defining LB shape, and we have this dynamic block, which in case of flex shape means we can define minimum and maximum bandwidth. Our load balancer will be associated with compartment and nested in our web subnet, the same subnet where we have our compute instances, right? Next, we are defining OCI load balancer listener, right? So it means our load balancer will be listening on a port 80 and protocol HTTP, right? Then, from backend perspective, we are defining Backendset, right? We have policy round robin and health checker, which will verify the nodes associated with the Backendset, right? And then we have two backends, right, associated with our Backendset, and each backend is related via IP address, right, a private IP address with our compute instances. Right now, as you can see, we have a first backend, and this first backend is associated with first web server, and we have also second backend, and this one is associated with our web server 2, right? And this is definition of our load balancer. Additionally, in outputs.tf, we will find public IP addresses of our load balancer, right? So we will be able to pick up the IP address from this output and access our load balancer. And that is all. And now we can move to our GitHub repository to use deploy button and deploy this lesson free. In my GitHub repository, let me go directly to lesson free load balancer subdirectory. I will scroll down to deploy button and I will click it. Right? Now I am moved into my tenancy, into Resource Manager Wizard. Again, I will accept terms and conditions. The zip file will be downloaded with the stack. Now I will go to proper compartment, so the stack will be created in this compartment. And next, I will click Next. As you can see, I can choose one availability domain for all of the elements. I can click on Show Advanced option. Of course, again, I can customize the networking. Additional thing, brand new, is a load balancer optional configuration. In this configuration, the default is flexible load balancer, which means we have minimum shape and maximum shape, but of course, we can choose the old-fashioned standard load balancer with settled static shape, static speed, right? But I prefer to use flex shapes. They are, let's say, more valid for modern deployments. I will stay with the original compute configuration with VM standard E3 flex, and then I will click Next. I will uncheck Run Apply because first I would like to see the plan. I will click on Create button, and it means now we have our stack ready to run jobs. First job is plan job. I will run plan. Is finished. Let me scroll down just to verify how many resources will be added, and we have 17 resources to be added. And now I will try to find out load balancer resources, 2 backends, Backendset, a listener, and probably somewhere you can find also load balancer as well. Now let me run Terraform apply, so apply job, and within a few minutes I think we'll have all of the elements, and again I'll pause. Okay, looks like apply job is finished. Let me scroll down to the very end, and we have 17 resources added, including load balancer public IP, just one. Let me move to outputs here in the resource manager, and I will just copy this public IP address of the load balancer, and I will check if it's available. Okay, now we are hitting web server 2. Now we are hitting web server 1. So load balancer round robin algorithm is working, and it really works. Let me go directly to load balancer in networking section in menu, and now as you can see we are moving to load balancer. We need to change the compartment to Foggy Kitchen compartment, and load balancer is in a okay health, so the overall health is okay. This is a public IP. We can go inside and we can see it's flexible. Now we can go to Backensets, and here's our backend, right? And as I have told you, weighted round robin policy, and we have some metrics in regards to our backend set. We can go to backends, and here we have IP addresses of our web servers. Okay, looks like ready. Let me return back to our stack, and I need to return to Terraform compartment to access the stack. And here is our apply job and the outputs. As you see, still our web servers are available, right, directly. because they are equipped with public IP. So that is interesting thing, right? And of course, we probably would like to hide them in the future. But this thing will be a part of the next lesson. Now, let me run terraform destroy, and I will destroy all of the elements, all of the resources. Okay, I will pause the recording and I will return back when the job will be finished. Okay, destroy job is finished. Let me scroll down. 17 resources destroyed. Let me verify that from console perspective. I will go directly to load balancers and I will check them in a Foggy Kitchen compartment. No items found. For networking, again, but this time in case of ECN, again, no items found. And compute instances, and here I'm expecting to have 2 web servers terminated. Okay, that's the end of this lesson. As I have mentioned, in the next lesson, we will just hide compute instances, web servers in a private subnet. I hope you will be interested. That's all. Thank you and see you soon.